Welcome to Space in Minutes, where space meets simplicity. New videos drop weekly, so subscribe and join our awesome cosmic community. If you're excited about making space more accessible for everyone, why not join us as a member? Your support really means everything to us. As a member, you can enjoy our videos without ads and help us create even more awesome content. What if I told you that in less than a minute, the entire universe sprang into existence? Space, time, and all the building blocks of reality. Where did it all come from? And what happened in those first incredible moments? Today, we're rewinding time, way back to the very first minute of the universe's existence. Scientists have pieced together this story using physics, math, and radiation that's billions of years old. And while some of it is still a mystery, what we do know is pretty incredible. Let's break it down. Let's begin with the Planck Epoch, the very first stage of the Big Bang timeline, less than y-43 seconds after it began. We start at a moment so early, it almost doesn't count. The Planck Epoch. Temperatures is an unthinkable 1032 Kelvin. That's 100 million trillion degrees. Far hotter than the core of any star, or even a supernova. At this stage, gravity, electromagnetism, and the strong and weak nuclear forces were likely one unified force. Here's the thing though, our physics breaks down here. This is the realm of quantum gravity, and we don't fully understand it. Think of it as a frontier, where our understanding fades into mystery. Like staring into the deep ocean without a light, the laws of nature blur and twist into the unknown. Now we move into the era of inflation, a tiny fraction of a second after the Big Bang, between 1:02:36 and 10:32 seconds. Next, inflation, not the kind that hits your wallet. This is where the universe exploded in size, faster than the speed of light, from subatomic ... to galaxy-sized. In a fraction of a second, a mysterious and flattened field drove this burst, smoothing out the universe. Tiny quantum ripples stretched across space, becoming the seeds of galaxies. Then, the field collapsed, releasing energy. Boom! Reheating begins. We now enter the reheating and particle production phase, from about 1:03 to 10:06 seconds after the Big Bang. Now we're in a sizzling hot particle soup. Quarks, gluons, leptons, and photons, ... everywhere. The temperature, about 1 trillion Kelvin. That's 1,000,000 times hotter than the core of the sun. Hot enough to melt atoms into their tiniest ingredients. So matter and antimatter keep popping into existence, ... then annihilating. Somehow, a tiny bit of matter survives. That tiny imbalance is why you and everything else exists. Next is the baryogenesis phase, roughly 10:06 to 10:02 seconds after the Big Bang. That imbalance has a name, baryogenesis. It may have involved something called CP violation, where the laws of physics slightly favor matter over antimatter, breaking what we do normally expect to be perfect symmetry between the two. It's still not fully understood, but it tipped the cosmic scales. Without it, no matter, no stars, no us. Now we reach the lepton era, from 10:02 to 10 seconds into the Big Bang timeline. Now, neutrinos, ghost-like particles, decouple and drift away. The universe is ruled by electrons, positrons, and more neutrinos. Electron-positron pairs start annihilating too, like soap bubbles popping into bursts of light, releasing energy. It's still hot, still chaotic, but things are beginning to thin out. Next comes nucleosynthesis, between 3 and about 20 minutes after the Big Bang. Finally, the universe cools down just enough ... for atomic nuclei to form. Hydrogen, helium, a sprinkle of lithium and deuterium. This is Big Bang nucleosynthesis. By the end, helium-4 makes up about 25% of the mass of the universe, a prediction that matches what we observe in space today. This alignment is one of the strongest pieces of evidence supporting the Big Bang theory. Lastly, we entered the photon era, starting around 20 minutes after the Big Bang and continuing for hundreds of thousands of years. Fusion winds down. The universe is too cool for more nuclear reactions. Now, photons, light particles, dominate, but they still bouncing off electrons like cosmic pinballs. Imagine a fog so thick that light cut unescape. Just ricocheting endlessly. It'll take another 380,000 years before light can travel freely. That ancient light. We call it the cosmic microwave background, like a faded photograph of the universe just after it became transparent, capturing its earliest visible moment. So there you have it. It's in just 1 minute. The universe unfolded from almost nothing into a place full of potential. The first sparks of everything we know today. That was only the beginning. If you enjoyed this journey, subscribe to Space and Minutes. We've got more mind-bending explorations of space, time, and everything in between, 1 minute at a time. Next up, we'll step beyond the light and explore one of the strangest objects in the cosmos, black holes. That's just one cosmic mystery explained in minutes. If you learned something new today, give it a like and let me know what you're curious about in the comments. I'll reply to every single one. And if you want to see more space, science, and imagination, all in under 10 minutes, subscribe for more. Thank you so much for watching. I'll see you next time. That's 1 minute. See you tomorrow.